Hello, I'm Dr. Ron England, and welcome to Python for Engineers. And today's topic, which is going to be a fun one, is how to do table-based interpolations. And these can get rather tricky if you start working with them. And let's first look at what we're actually trying to do. So let me pull over this Excel spreadsheet right here. And let's say what we're trying to do in this Excel spreadsheet, and I don't think you need all the header information, so let's just kind of move that guy right there so we can fit as much as we can in. This is just a typical table of values, and what you might have to do in an engineering job is say, well, suppose I need to figure out what is at the column with the value of 10 and the row with the value of 70, and it's pretty easy to take those two pieces right there, and I think what I'll do is I'll just give you a little bit of highlighting to just say, I can bring those two together and say, well, the value that I'm looking at that I need, if I'm going to be using this value from the columns and this value from the rows, is 0.133. It's a simple lookup that we've got going right there. However, what if I have a column value of 8 and a row value of 67? Well, in that case, what you're going to end up doing here is you're going to end up having to figure out something that is inside of these values that I've got highlighted right here, but it's going to be an interpolation in both the column and an interpolation in the row. So this can get a little bit tricky here. So let's first just kind of take that idea here, and let's go over here to my Python, which is where I'm going to solve this problem. And I could actually sit down by hand and work that whole thing out, because in the reality is you're only going to be working with, when you're solving this, you're only going to be working with these four values. But there's ways to be able to solve this that are relatively straightforward. So first thing let's do is I need to go ahead and close my spreadsheet so I can go ahead and read it in. And but before I do that, I'm going to say, you know what? Let's just take a simple example of an interpolation of an x and a y here. All right, so I'm going to take these two x's and y's here, and let's suppose I want to, and let's see, bring those in, and let's go ahead and bring in numpy, and numpy's got an interpolation, and I have actually shown you how to do this by hand, but this is relatively easy. So I bring that in. Let me go ahead and print out the value of a. And what I did here is I did the interpolation, which says find the value of y where x is actually at 2.3. So if I look at my x values, which run from 0 to 6, and they're linearly spaced, 2.3 is going to be somewhere between the 2 and the 3, which means it's going to be somewhere between 0.11 and 0.6. And if you look at 2.3, it's a relatively straightforward interpolation. It's going to be 2.3 minus 2 over 3 minus 2. So it's going to be 1/3 of the way between the two values of 0.11 and 0.6. So it's going to be 0.11 plus the difference, the 0.3 times the difference of those two. Or the interpolation will just do it all. So if I print out A, go ahead and bring that over so I can see it. And the value is 0.26. Not terribly, that really isn't that hard. Now the one that I'm actually doing, that's just a standard interpolation between two arrays. It's done in NumPy. It's easy to do. But that problem that I just gave you with the table base is a little bit more challenging. So let's look at that one. So the first thing let's do is, since I've got that in Excel, let's just bring that table in as a data frame. So I'm going to go ahead and bring this table in as a data frame, and I'll come up here, the CN table, I'll pull it up, and there's that entire Excel spreadsheet over here as a data frame. I've got the column indexes just as they showed on the spreadsheet, and the row indexes just as they showed here. And let's solve that same problem where I had 8 and 67. So so what I need to do, first thing I'm going to do is I'm just going to look at the header to make sure that I've got it in the way that I want it. That looks pretty fine. The header's okay. Now, the first thing I'm going to do is I'm going to bring in the column at 5 and the column at 10, because the column that I have to make, which is a virtual column at 8, is going to be between those two columns. And I just want to show you can do this. So I bring in those two in by using the loc. The LOC is going to slice out the column at row 5, the column with the index of 5, and the 10p is going to be the column with the index of 10. So I'm just going to bring those two pieces in as series, and you can see there's one series, and then there's the 10, there's the other series. And if you went to check, you'd see that those are the columns in that data frame where the index of the column is 5 and the other one where the index of the column is 10. Now, these are indexes as far as the system is concerned. Those indexes are indexes of 10. I mean, they can be integers or strings. But I'm going to have to do something with that later on. I have to make sure that they're integers because I got to do some interpolation. Now, with those two columns in, I need to make a third column, which is at the position 8. So I'm going to have to do a little bit of math here. So this is just to demonstrate that you can do math with the columns. The series themselves you can do math with. So remember I said that if you are looking to find something that's at the position 8, well, the interpolation is the 8 minus the 5, the previous column, over the 10 minus 5. And you can see that I've got that right there. And I can create a new virtual column, booyah, right there called column 8P. And if you looked at this, you would actually see that the values of this column are going to be between the values of the column 5 and the column 10. So now I've actually created a new column that is right there in the middle. Now, the next thing that I need to do this is I need to take the row, I need to take the values at the row indexes, and I need to make those into an array that I can then easily go ahead and use that interpolation function. Because the interpolation function just says, give me the x values, give me the y values, make them array-like, and if they're array-like, I can go ahead and I can do an interpolation. So now what I'll do is I'll then create that by taking this, the CN table, which is my data frame of the whole thing, the index.values as type int, so it's going to bring them all back as integers. So now I've got the row indexes, and let's look at those real quick. There's the row indexes, and if you remember back to the table, they started at 30 and they went up to 98, so I've got them all. Now, I can just apply the interpolation. Woohoo! I can just use, remember I wanted to find it at column 8, row 67. Well, I've got the row indexes set. 67 is going to be where I'm going to be looking at the row index, and I've got the column 8. So now I can just go ahead and compile that one. And now if I look at the V value is 0.10916. If I looked back at the table, see 0.10916, and we can see if that makes sense. Okay, somewhere in here, okay, somewhere at 67, somewhere in this little area right here is where that guy's going to apply, and the value is 0.109 roughly, which looks to be right there in the middle of those, so it does make physical sense that it actually came out that way. Now, I'm going to give you a little bit of a bonus right here. I am going to plot the surface of that entire data frame. So this is just kind of a little bit of a bonus. So to do that, I now have the row indexes, which are going to be my x-axis. Oh, I'm sorry, those are going to make those my y-axis values. I'm going to take the column indexes and make those my x-axis values, but I have to get them first. So I have to do cntable.columns.values as types because I want to bring them as integers. And then I need to bring in the data, the z values on, because I'm going to plot this 3D. It's a 3D plot. I need the z values. I'm going to call that, you know what, instead of calling that data, I'm just going to call that z. Makes more sense. Those are the values. Then I need to bring in the, I need to import the pie plot, and also to do 3D plots, I need to import from the toolkits the mplot 3D. Okay, so I'm going to bring those guys in, and now I'm going to make make the plot, the background plot. And one of the things I have to do to make this plot look pretty is I have to mesh out the grid of the column and the row indexes so that they'll plot nice. And that's really relatively straightforward to do here. I can just use in NumPy, there's a mesh grid that meshes them out for you. So I'm going to make the background plot, put those guys together, and now I can run the plot surface. I want to do it as a surface plot. So I can now run the surface plot right here and then show it. And I'm going to put, actually what's fun is I'm going to put the whole thing together. I'm just going to do the whole thing. Just boom. And there it is. It's, oops, you know what? XYX, I was looking at it going, that does not look like a surface plot. That looks like a linear. It's actually XYZ. I'm just going to do the whole thing once more. I don't have to do the whole thing once more. And then that looks actually very much like the curve of the actual data that I brought in originally. Sometimes it's a good idea to bring it in as a curve right from the start and plot it so you see what you're working with. It's also important to realize that if you're going to be doing these types of interpolations between values, that the values all need to be going in the, they need to either be increasing or decreasing, but you can't do this on a curved surface with both increasing and decreasing values, because you would have 2 points that would fit the interpolation, not just 1 point. But hopefully I showed you a great methodology for doing tabular interpolation and a little bonus of putting together a nice little 3D plot of what we actually had in that series of data. The reason I did this is because this type of stuff, oops, I closed my Excel, this type of stuff that where you're actually doing a tabular lookup table, that's really common in a lot of different fields. So it's a good idea to know how to do it if you actually have to do it with interpolation. So thank you very much. Good programming. Hope you're enjoying this.